Hello guys, and welcome to StaadPro. So today we'll be talking about plot plan. We're going to discuss everything about plot plan today. So now before we start our plot plan, the number one information we'll be needing is what is called topographical survey drawing. So but if the topographical drawing is not available, you can still be doing something if you know the size of the plot. If the client can tell you the size of the plot, you can just from the size of the plot you start doing something. But what will validate the size is the topographical drawing. So topographical drawing is what I'm displaying here on the screen. So you can see the spot height. This spot height tells you the natural ground level of the site of the location. So you can see 13.33 and here is 14. So it means that this place is lower than this place. Okay, so this is 14.20, this is 13, so this is lower again. Okay, so somewhere in the middle is higher, and you have this as the lower zone and this other side as the lower zone. You can see the contours. Okay, so this is very important, but what we need in this plot plan is actually the edge coordinates, so that we know the extent of the property that has been procured by the client. You get. So I have already moved to this because I've gotten what I wanted. So initially this topo drawing, let me take it back to where it was before I started working on the plot plan. Okay, so this is what it was. Let me take it back to this point. Yeah, so this is what it is. You can see, so the client procured this whole plot. The area they procured is that 300 meter by 300 meter. That's what they procured. So but because they are not building a gas processing plant inside this area, they only wanted to get their Christmas trees. Okay, so the important thing I need there is just the boundary coordinates. The boundary coordinates. So in the report, you definitely see the coordinates of this boundary, the four corners especially. So what you do to confirm is this coordinate is actually listed in the report, and this particular point is labeled. So it has a label for you to know that this is where the coordinate is. So I will show us how to check this coordinate. So this is easting and we have nothing. So this coordinate is what the surveyors will use to get this particular location. So if you give a surveyor a coordinate of a particular point, when they get to site, they'll be able to use that coordinate to establish that point on site. That's why coordinates are very important. So I'll simply do ID for me to confirm that this coordinate is correct. I'll type ID on my laptop and click on enter. Then I'll click on this exact point. Make sure it's at that point. Then we now check the coordinate. So look at my values here under here. So here is the easting. Easting is X. X is 436345.650. So this easting is correct. Then Y is 189811.76 is also correct. So that means this particular topo drawing is georeferenced. You get. So any foundation you are putting inside this or within this area, you can simply establish the coordinates of that foundation. So that's the most important thing we need to establish in this our plot plan, because each foundation we are putting in here, we have to generate what is called the foundation coordinates, which will help the surveyors during construction to be able to set out those foundations. Again, so the information we are getting from the topo survey is the coordinate of the location, which will help us to generate the coordinates of the foundation. I hope that one is very clear now. So after generating this code, after confirming that the coordinates are correct, that's when I now moved this topo survey away, because I don't need all these spot heights. It is when we start our site grading plan that we will need the spot height. That one is used to prepare the site and grade it. So that's where this spot height is going to be used. For now, I've confirmed that the coordinates are correct. So for you, because I've done this confirmation before. That's why I'm not confirming all that. You're supposed to also confirm this other one. All the four corners has to be confirmed. So all the four coordinates has to be correct. You get. So if they are not correct, you can now inform the clients, inform your boss in the office that see, oh, these are not aligning or they are not correct. You get. So they can figure it out and see if it is a problem or an issue from the surveyors, or it can be from anywhere. Exactly. But this is what to do. This is how to go about it. So now that we have confirmed the 4-point coordinates and they are correct, so I will simply take it back to where I will remove all this and okay. So while removing it, you have to be sure that this location is where you have your plot plan, so that the coordinate will not be moved. If I copy all these drawings and move it away from here, if I do something like this, I have changed the coordinates of this drawing. So even if I do ID and pick any coordinates, it's not going to be correct. You get it? It's how you have changed it exactly. So I will undo and take it so that they go back. So this is where it is. So I'm not going to move. My plot plan is going to be done here. So what I will delete is all these spot heights. I will delete all these spot heights and clean up everywhere here and make sure I do my drawing inside this place. So I'll just simply do undo so that this is what I have now. So this is the original location of the site as it is on ground. So inside it is where I have my plot plan. So this is project requirement. If this is a gas station where all the whole site is going to be used, so what we normally do is this line here is what is called property line, the boundary line. When you buy a plot of land, you have your beacons. That line connecting your beacon is what is called the property line. That's the whole property, but that's the boundary. So now in oil and gas, we don't start building from the property line. You have to give a distance away from the property line to put your fence. So and normally what we have as standard is 1 meter. So if this is a gas station where we are gas processing plant rather, where we need to make use of the whole purchased area, so we can just offset 1 meter. Okay, and sorry, offset 1 meter. Okay, so this is 1 meter offset. So it's from this offset now that we can start our construction or design. So this line now that I've offset inward can be my fence line. You get. But in this case, this particular client is just using this location for drilling. They just want to have their wells here, while they will now pipe the hydrocarbon to another site where they have their processing plant. So this is just what they want to use this place for. So they don't actually need the whole area. They just needed the drilling location to be within the procured facility. So now that's the requirement. So you also need to work with the requirements of your own client. The clients will always tell you what they want. So in this particular one, this is project requirement. So I now developed a plot plan inside this facility. So within the facility is still the properties of the client within the facility. So but inside here is where we have this thing. So now, like I said before, I have created my plot plan here. Let me confirm this coordinate if it is correct. Simple ID command, enter. I will click on this midpoint. So we have a 436 453.1. So it's correct. So that's to tell you that whatever I'm building, I must build it inside this place, inside this topographical drawing, so that the coordinate will not change. Anything that changes this coordinates, once the construction team gets to site and they start using your coordinate, the coordinate will be taking them to another location where the property of the client is not extended to. It will be falling into another person's property, and they will begin to call you the engineer that you have done rubbish design, I've done nonsense design and stuff. So I have to be very careful with this coordinate. So now the first thing to create is your fence line, which shows the boundary or the size of the facility you want to design. So in this particular case, we used block fence. The client requested for a block fence, but in oil and gas industries, what is common is citadel fencing or concrete fence. These are very a see-through fence, a fence that is transparent, you can see from afar, and that one has more security advantage because when you have a security inside your facility, they can see through the fence. So before anybody could approach the fence, they've already seen the person. But when it is block fence, they will not see the person from inside, except if they have some security towers where some person will be up there and they will be able to see outside the facility. Okay, so but maybe in during locations like this, during when the wells are up and running, maybe they will not be having a lot of securities inside. You get, so that's why they don't want it to be see-through. So people will not know when the place is empty and they begin to come in and maybe steal one or two things or something like that. I don't know their reasons as well, but out of my own experience, we normally design citadel fences and coping fence for facilities like this. So okay, now you determine your fence line, taking recognizance of your access road. So this is access road. This access road is where this approach now to this plant. So from there you have your access gate. Now every facility must have emergency gate. So this is the emergency gate. Everybody that is coming to this plant will come from the access. Everybody comes and leaves from this access, but there must still be an exit gate. It is standard in oil and gas, so you must have an exit gate. This is in case if there is any fire outbreak, somebody that is here shouldn't start coming to this place before the person can escape the facility. You can follow which one that is closer to you at that point to escape. Okay, that one is for gates. Then after that we see the access road, internal road. Actually internal road there, it's actually what determines how you're going to route through your internal road is based on what you have inside the facility. Like if you look at this one, you have a pond wall and the diesel tank. Of course, from time to time vehicles will be bringing in diesel to this place. So we need roads that the vehicle can ply to get to this place. So easy access to the equipment is very important for maintenance purposes. So here we have a test separator and other flow testing equipment. So the road, so this is why this road has to go around to be able to get to all these points. We have portable water tank. During maintenance and rest of them, vehicles supposed to be coming close to this place. So this is internal road. So while you are placing your internal road, you should also take note of how you intend to drain the facility in terms of where storm water during rainy season. You get, so you cannot expect storm water. This road is round, so you can't expect storm water within this area to jump the roads. Okay, so you need to create something like a culvert so that when the stormwater enters into the drain and it flows down to be able to follow this culvert, then enter this other drain and goes out of the facility. So the same thing happens here, and we also have the same thing here. So stormwater is not advised to stay on the road. Of course, if you want your road to last, if you have to camber it in such a way that once it is raining or once the rain stops, there won't be any stormwater on the road. Otherwise, the road will not will not stay long, and it will begin to develop some potholes. Get, so at this point, if you have actually gained something from this class, I will ask you to please give me a thumbs up. Just give me a thumbs, like this video, share this video. Also comment if you have any question. You can ask me on the comment section so that I can attend to it, or maybe it will give me an idea of another thing I should do a video for, so that you have a better understanding. Okay, so but most importantly, just give me a thumbs up. If you have not subscribed, please just hit the subscription button and also the like button. Like I said in our last class, this particular project, which is called drilling location, I'm going to explain everything that we have designed here. All the items, all the foundations is going to be designed, is going to be explained in this channel. So just stay tuned and also share the video to your friends and some colleagues in your office so that all of you can get value of it. And you can as well write down a question. If you have a question for clarification or anything, or a contribution even, is also welcomed in this channel. Just write your comment. We can address it and look into it. Okay, so after that, the drainage, we also have perimeter drain. So of course, if you have designed drainage before, it has to do with catchment areas. So we have this other area here, so this catchment area outside the internal road. So that one cannot just be working freely. So it should be channeled into a drain, and from there to leave the facility. Okay, so we have internal perimeter drain, sorry, we have perimeter drain right around the facility. You get, so, but we also have another thing we called oil trap. So this oil trap is because in the course of drilling, we have some oils that might be spilling out or something like that, and when the rain falls, you have a combination of stormwater and oil entering into this drainage. And when they get to all this oil trap, the work of this oil trap is to be able to trap the oil, just as the name implies, to be able to trap the oil within that pit. So when the pit is kind of has enough quantity of oil, it can be drained, drained out. Yes, or discharged. What is not ideal to discharge oil to the surrounding, even though once they discharge it immediately, it is still within their own facility. But you never can tell the quantity of rain that might fall and it will go beyond their facility and then enter another person's farmland. So even the villagers can even begin to sue the company, and no company wants that. So it's good to have oil trap so that whatever that is leaving the facility will just be pure storm water and nothing that will harm anybody's farmland. Okay, so now we have the major foundation, which is the cellar slab. So this is where the rig operation is going to happen. The rig is going to be mounted here. Okay, so in this particular project, we have three holes. They are going to bore three. They're going to drill three wells in this particular one. Some cases is one, some is five, depending. So in this one is going to be three. So this is where we have the pit. The pit is actually in the within the area we have the wells. So this is what it is. So we are going to also explain how this foundation is designed. This is a very special design. So we are going to have the rig mounted on this pit. So this slab is meant to carry that rig. The rig is actually a heavy equipment, and it has a lot of features that has to be taken care of during design. Okay, so we have the first borehole, and the coordinate is actually stated, which is this one is the north and this is east. So with their surveyor, they will be able to locate the first borehole point for the well. So when this well, when they have finished digging this well, and they do all the piping and casing, it's going to come out as it's like Christmas tree. I don't know if you have heard what Christmas tree is. You can tell us in the comment section what you think Christmas tree is. Yes, you can just write down in the comment section. People might have different opinion. It's not the type of Santa Claus Christmas that we used to eat rice and chicken. So this one is an oil well. If you look at the nature after construction, it actually looks like a tree, but it's a combination of valves and spools and a lot of connections. So but it just the way it helps to regulate the pit, the well itself. So from there we have oil, and from there the piping, what is called flow lines, going to the processing plant. Okay, so all these wells hopefully are supposed to be producing hydrocarbons, either crude or gas. Okay, so this is cellar pit where the drilling is going to be happening. That's the drilling itself. This is the reason for the project. Now we have also pump. This is pump. Of course, pump is necessary. So mods are being used for drilling. Okay, so this is area where we have the mud tanks. We're going to have mud tanks lined up in this location. It's going to be lined up in this location. So this mud tank is going to be containing muds. So this pump helps to pump in the mud, during the drilling process. Okay, so the generator here is the generator foundation. Generator is what will power this pump. Generator powers the pump and the rest of them. So this paved area is for the for easy movement of workers during operation. So we have waste pits. These are very, very important items which we need to have in our drilling location. Waste pit is during the operation, anything called waste can come inside that pit. Okay, so now let's look at other foundations within the area. So let me just talk about the security tower. Of course, there is need to have security towers. Some of these locations are very remote, so you need to just have is in the bush. Some of them are most of them very inside bush. So some miscreants can attack or anything can happen. So there's need to have a security tower that is very high, higher than the fence. So when you have your security guys at the top, they'll be able to see very far from there. So if anybody has a group of persons are planning to invade the area, they will be able to see them on time, and they can also reinforce to attack. You get, so we have it two. It's usually two at least. We have two towers. I have one here and another one here. So this is um to be able to secure this place. You get, so if the facility is bigger, very big, of course you have it at the four corners, depending on the size of the site. You have it at the four corners. Okay, so we have gatehouse. This is gatehouse, very close to the fence. So anybody that comes in, the gate person will come and open the gate and they will ask you questions. So you explain yourself. So if it is something that needs you to come to reception, you can cross over to the other side and enter reception office. Either you wait here or maybe for induction or anything before you now go inside for if you are here to do any work or you are here to see anybody. Okay, so that's just that. Okay, so this is septic tank. This septic tank is for the toilet in the guest house, and we have communication mast. Communication mast is for communication. Of course, that is what it is used for. Some of these locations don't have network. If anybody is telling that they is going for outside work, maybe for drilling and the rest of the, you discover that most times when you call them on phone, their number don't normally connect. But this is just one of the reasons. They have telecommunication masts to get their own network. So this is the storage area, the area where they can store some certain things during operation. And we have a solar farm. Okay, but this particular location is planned to be powered with solar. So they have a solar farm where the solar panels will be installed. So they will install the solar panels, and from there they will know how to. The electrical guys will they know best. So we do foundation for this solar farm. It's part of what we are going to show us. So we have test separator and other flow testing equipment. So this is a foundation as well, so where they can keep all those. We have water well. We also have chemical storage area. During the process, they need to store chemical somewhere. So this is where the chemical is being stored. So we have a shelter here and the foundation, and we also have a bond wall for it as well. So okay, this is actually another special design, because we have a bituminous floor for this chemical storage area. So if you want to know why we have bituminous floor, you can as well stay glued. When we get to that, we explain to you very well. So here we have bond wall and diesel tank. Of course, every diesel tank foundation needs a bond wall around it, because in case if the tank lets loose of its content, the content is not supposed to spill out and start affecting the environment. So the bond wall is the bond wall is to hold the spillage from the tank. If the tank fails completely, this bond wall is designed to hold the total quantity of that of the diesel in the tank. So that's the essence of this bond wall you get. So we have a fire water tank. In the fire water tank, in case of fire outbreak, they can use their fire hydrant and rest of them, and they will be able to fight the fire outbreak. Okay, so we also have water well. Water well has two locations in this place, and we have potable water as well. So during the operation, during the manning of the place, of course there is need to have potable water. And they also have a water treatment plant where this potable water will be treated, and or even if it's not going to be treated, they still need potable water for the toilets, flushing of toilets and the rest of them, and even canteen operations. Okay, so we have a fire hydrant. So another thing I need to tell you is that in developing your plot plan, it's not just civil structural input that we need here. You also, like the location of this fire hydrant, is not civil structural person that will tell you where the hydrant is going to be. You get, so we have other departments that play load. Mechanical, they play a role in this, mechanical instrumentation. Okay, so a lot of them, technical safety, these are the people that will actually tell you where they want what to be. They want this one to be there, they want that one to be there. So it's a teamwork, thing. You get, so all these equipment are not civil equipment. They are mechanical will tell you this will be here, that will be there, that will be there. You get, but in case you don't have a strong mechanical person, someone that is not well experienced, of course you should also have an idea of how to place your foundations. We have office area and the septic tank around it. For in this particular project, they plan to use caravan for this office area. So that means we just do foundation for the caravan. Yes, we also have canteen. This canteen is also caravan. We're going to use caravan for it. You have HSE, rig manager's office. You see, we have office area B and septic tank. So this one is pipe rack, which is this pipe rack is not the normal pipe rack where you that is supporting pipes. So this one is because of the flow line. Like I told you that they are not going to they don't have a processing plant in this area. This is just during a location, so they will just have these wells here. So when these wells come up, they are going to pipe them, with flow lines down to wherever they have the processing plant, or wherever they have another client they want to supply these resources to, and they will have a meter around that place that meters what they are sending to the client, so that at the end of the day the client will be able to pay them what they have supplied them. You get, so because of that, they will need a lay down area where those pipes are going to be packed. So we provide foundation for them, so they can just come and pack the pipes here, and from here they will be taking them one by one to lay, and take them to wherever they are taking the resources to. So that's the essence of the pipe rack. Is also called lay down area. So now a parking lot. This is parking lot. If you have a vehicle, if once you drive in and they are checked at the gate, then you can come here and park. This is basically what this is all about. This is plot plan. So in my sheet 2, I did something else. I tried to show some dimensions, which is very necessary, but you shouldn't do it in a way that the whole place will be clustered. So show some dimensions, and I tagged every foundation. Every foundation is tagged. If you look at, this is 01, this is 02, all of them are tagged. So if you come to this table, this is why I said coordinates are very, very important in plot plan drawings. So 01 is diesel tank bond wall. So if you don't know what it is, if you come to this table, the table will describe what the foundation is for you, and the coordinate of that particular point being referenced is given. This is easting and this is northing. And make sure that your coordinates are in 3 decimal points. It's very, very necessary. So if you make it to a whole number, you'll be losing some. You can imagine if these coordinates are in meters. Actually, they are meters. Okay, so okay, I can put it here. Is supposed to be stated clearly that the coordinates are in meters. Okay, so just in brackets I'll put meter for the same thing for here. Okay, so assuming if you approximate this value to 436,488, is now up to 5, so 488 approximately, it means we are losing 0.43. That is 430. If I approximate, it should be 440. 440 is much difference. You get, so, and this one now, if we approximate this to 36 instead of 5.533, it means we have added 470 or 467 is a big value. So these two values now has shifted the foundation if you approximate. So coordinates shouldn't be approximated. Just leave it at three decimal places. If you have, you can even leave it at four decimal places. It's very very important. Coordinates. When you are doing foundation coordinates, please don't approximate. Leave it at three or four decimal places. You get. So this is the essence of this table. All the foundations are captured here with respect to their tags, and the coordinates are there. So this is what the client is expected to see from your plot plan. So aside this plot plan, we also have what is called foundation layout. But some persons normally use plot plan as foundation layout. What is foundation layout? Foundation layout is, all these things I just showed here, like this communication mast, we just represented it with a box just to show you the location of this mast. But if I'm doing my foundation layout, this mast, depending on what was designed, if it is a matte foundation, for example, we are now going to bring in the exact sizes of that matte foundation. You bring it in here and put it where it's supposed to be, and that might lead to a change in this coordinate, because when you put the foundation might be smaller than what this box that we put here, and when it is smaller, you have to now make some adjustments and put the correct coordinate. So that is what we normally do in foundation layout. So in foundation layout, we put the, just like this one. This one is 70, this one is already okay. Are you getting me? But this gatehouse, we need to put the exact gatehouse we designed and the orientation. You put it there. Then you can now pick a particular point and show the coordinate. Are you getting me? Then this other parking lot is okay. This pipe rack is okay. This office area is another. When they bring the caravan, you need to know the actual sizes of the caravan and put it inside this drawing. So is it that if you have foundation layout as one of the documents you are producing this in your own project, there is where you are going to do this. You are going to be putting the actual foundations, but this plot plan can go like this. But before it gets approval, all the foundations are going to come in the way they are, the way they have been designed. You get. Then the cellar pits and the mud pump, the pump foundations, they are just the way they are. The bond walls and the rest of them. I'm just talking about the buildings and the masts. You get. So this is just plot plan. So if you have a question, you can just communicate. You can communicate that on the comment section. I'm going to be attending to your question one after the other. So if you think I've missed something out, you can still bring it up on the comment section. I will look at it and see if it is something I should do a video for, so that others can benefit from there. Let us make this an interactive section. Let us make it an interesting one. Let us make it very very educative. You understand? So I can as well learn from you. If you have any idea, if you think I am not doing justice to this, you can feel free, just put it up there in the comment section. Let us look at what you are talking about. I can learn from there, and every other person can also learn. Nobody is an island of knowledge. So I think I'm going to stop here. So what you need is to produce your plot plan. You need topographical survey, which looks like this. From there, the client requirement. Are you using the whole site plot for your plot plan, or you need to just do something smaller? So if that is the case, you begin to generate your plot plan. But before then, you have to confirm that the topo drawing you have is georeferenced. The coordinates, are they correct? Is it something you can reference? So if that is okay, you continue, you reference them. Okay, so of course I put the drawing in backsheet. This backsheet is showing the property line. That is where you actually appreciate the line weights, because I like using paper space for my drawings, where I draw to scale and observe all the other drawing standard. As a civil engineer, you are supposed to know how to use AutoCAD, and or even BricsCAD. Any drafting software, you need to know at least one to back up your or that, because you don't need anybody to do some sketches for you. You can be doing it yourself. And even when somebody does something for you and needed to send it out, and maybe there's just a little thing you need to change in the drawing, before you send it out, and the deadline is far, far, far approaching, so you don't need to send it back to the person. You can quickly, do that little changes and still send your document and meet up with the target. It gets very, very necessary. In my own where I work today, they no longer employ engineers who don't use AutoCAD. Sorry, if you cannot use AutoCAD, they will see you as, you don't need somebody that will just be doing a report for us. You should also be free to assist him in other few things, or even assist yourself. It's not when you need to put a sketch in your report, you'll be asking somebody that is busy with design to help you sketch it out. So you should also try to know how to use AutoCAD. Okay, so this is paper space for that, showing the whole location, the property that the client bought, and the location of the plot plan itself. When the second sheet shows just the plot plan itself, and the the coordinate table, foundation coordinates table. So this is where I will stop today. The next class is going to be on side grading drawing. I'm going to be showing us how side grading drawing is done. So stay tuned. This is plot plan. If you think I've not done justice to this, you can still call me back. Whatever you think I've missed out, just let me know. I can still do a video for that. If you are still yet to subscribe to my channel, I beg you to please do that right away. Give me a thumbs up. That thumbs up is very, very necessary for me. Just give me a thumbs up. Nobody is charging you money for that. Just like this video. Like this video. Like the video. Okay, see you next time. Thank you very much. Bye.